Today's video will explain the three algorithm abstraction design patterns. Hello, I'm James Helfrich. There are three algorithm abstraction design patterns. There's the strategy, the template method, and the decorator. As the name suggests, algorithm abstraction is about extracting, well, algorithms. This is about taking a function or method, a verb, and separating it from the rest of the application so it can be independently changed, adapted, assigned, and modified. This video will demonstrate the three algorithm abstraction design patterns in the context of a real-world application. So we'll start with a financial application that has an account. An account has a balance and transactions, a name, connection to the bank, institution name, and a collection of different methods. And in a traditional object-oriented design, I'm going to have a savings account, a money market, an IRA, a Visa, and a collection of other different accounts. And each one of these can be related through inheritance to the account base class. In other words, all these methods, account balance, display account info, transfer, get balance, all these other things are virtual functions, and my derived class will implement them. And this is what I expect. Observe that both the base class and all the derived classes are nouns because that's what classes represent, which is nouns. I would like to look at the update balance method, which means that my savings account, my money market, my IRA, all these other ones are going to have their own version of update balance according to the various rules associated with these different account types. Once again, this is what I expect. So let's begin with the strategy design pattern. Note how every derived class is a noun corresponding to each special type of account, but note how every derived class has all the methods which make it distinct from the base class, which is once again a fundamental way we do object-oriented design. But note how there's a lot of duplication in the functionality of our update balance method, because each one needs to go and sum the transactions and then maybe apply fees or maybe apply interest or whatever. Now, the strategy design pattern involves identifying collections of related methods, each of which honors the same contract. These methods are removed from the inheritance hierarchy from which they came and are then placed in their own inheritance hierarchy. This new inheritance hierarchy only represents the algorithm being abstracted. Okay, so let's take a look at where we were before. Now, the first thing I'm going to do here is I'm going to create an update balance class. And this has a single method called update balance. Now, observe that this is a verb name, update balance, and that's because the only thing this class does is carries a single verb, this method. And this method is a pure virtual function. It's virtual because it's italic, and it's pure because it equals 0, which means update balance is now an abstract class. Now, there are several different types of updates we can do. We can update a credit card, when this can work for the Visa, the MasterCard, and the American Express. We can update loans, which can work with the mortgage, update the market, which is going to work for the IRA and 401k, and update the asset, which will work for my savings and checking. Each one of these is going to inherit off the update balance class, and each one of them is going to have their own version of the update balance method. Now, how is the update balance going to be related to account? What I'm going to do is make a new variable called update type, which will be an instance of update balance, which means account is going to have exactly one update balance by composition. This is the strategy method. Now, once I've done this, in the account class, I used to have the update balance virtual function, and now it's going to be a non-virtual function, and then which means that all the derived classes will no longer have their own version of it. Because now the update balance method in the account class will then call the update balance in the strategy. Now I went from having, 12 different versions of update balance to now having 4 because I've removed all the redundancy, and this is one of the main wins of the strategy. But notice also that I can change how I update a balance at runtime by reassigning that update type method. Okay, so that was the template method. But know how each concrete strategy has some code duplicated. In other words, my update credit, update loan, update market, and update asset all need to sum up all the transactions and then do some other stuff. And now we have some redundancy there. Note how each concrete strategy completes essentially the same steps. Number 1 is going to retrieve the market value. So I'm going to see what my new value is for my stock or whatever. Number 2 is going to sum all the transactions. Number 3 is going to apply any interest. And finally, number 4 is going to apply all the fees. It'd be wonderful if we can leverage this functionality by taking these same 4 steps and applying them to the different update types. So the template method is the design pattern where the components of an algorithm are separated into steps, each of which is defined in derived classes. These steps are then executed from a single method. So we're going back to the strategy we had before here. And notice how my update balance is now going to have several different steps. It's going to say get market, sum transactions, apply fees, and apply interest. Now notice the update and balance method is not virtual anymore, it's just a public method. But the get market, the sum transactions, apply fees, and apply interest are protected, which means the client account does not have access to it. The sum transactions is not virtual, which means we're going to use that same version in all the derived classes, but get market, apply fees, and apply interest may. Now, right now, each of these virtual functions does nothing. They're empty. It's not a pure virtual function, they just have no body. But for the update credit version, I'm going to apply my own fees. So my interest or my annual fees or whatever. For my update loan, I'll apply interest. For my update market, I'll get the market value. And for my update asset, like a check and a savings account, I may both apply fees as well as apply interest. With this new design, I have basically no duplicate functionality. It also gives me the same advantage I had before in a strategy, namely I can update balance in different ways by simply updating the update type member variable in the account type. Okay, so notice how the template method always executes exactly the same steps in exactly the same order. That's what the template method does. Notice how many of the steps are empty. For an example, with a credit card like a Visa, I don't have to get the market value. I don't have to apply interest. All I'm going to do is sum the transactions and apply the fees. Wouldn't it be great if we can avoid those empty method calls? Well, the decorator design pattern is a technique for adding a sequence of tasks to an app algorithm so it can be easily executed. The client assembles each sequence. Each task in the sequence is executed in order. So let's see how this works here. I'm going to start off with just my account type with all of my derived classes. And I'm going to create a new method called apply. And apply is initially a pure virtual function, so I cannot instantiate an object of type apply. Now, in my account class, I'm going to have an apply list, which is going to be a collection of apply. And how many am I going to have here? Well, 0 to many. If I have none, then I'm not going to update the balance at all, but I can apply different ways. And what different ways are there to apply? Well, I can sum all the transactions, and this is inherited off apply. I can apply interest. I can apply late fees. I can apply update, which will get the market value for my stock or my 401k. I can apply transaction fees for like foreign transaction fees or whatever, and I can apply tax as necessary. When I create an account, I can add as many different apply types as I want. So for an example, my checking account may sum the transactions, apply interest, and apply a transaction fee. But then after my account reaches a different status, I may remove the transaction fee. So now I only apply interest and sum my transactions. So I can add and remove different apply types to my account on the fly, and I only execute the ones that are necessary and relevant for this particular application. We can learn more about this in the strategy, template method, and decorator section of the algorithm abstraction chapter of the software design textbook.